Hello everyone, welcome to the section, and in this section we are going to collect all the movie plots that we want using Beautifulsoup Library. So in short, Beautifulsoup is a Python package for parsing HTML and XML documents. So you can visit any web page and you can parse the content that's there and then store it in database or pandas data frame, however you want. So let's search for list of American films by year. So I've just made a search for list of American films by year and Wikipedia. Let me click on this first link. So when I land on the first link, I can see all the American movies that are listed by year. So for our use case, we are going to scrape from 2005 to 2021. The simple reason is that if some of the things might break format in 2022 or 23, we don't want to include them. So basically taking from 2005 to 2021, you can also do the same thing for other years. Just make sure that the formatting is similar. So whatever parser that you write for each link, that works across all the films, all the web pages. That's what you need to make sure. Let's first take this link 2005. So you can see that the URL is in this format: wikipedia.org, wiki and list of American films of 2005. And similarly, if you click on 2006, the link is similar except that there is change of 2005 to 2006 here. So the first thing is, before even parsing the data, you need to understand how the data is and in which format. So that's why we are looking at these URLs. So basically we'll go from 2005 to 2022, and in each link, that is in each year's link, you have this kind of format, and our goal is to collect all these titles. So here they are from January to March, but assume that you collect all the things from January to March as well as from April to June, and also from July to September, whatever is present, right? All the movies that got released. So essentially what are you going to do? You need to go to every year's page, and in that there is movie title, and we need to go inside that, and here's where the plot is, and our goal is to collect all the movie plots. You can see that the movie plot is right here. So for example, our goal is just to collect all these movie titles as well as the movie plots. So if you are able to collect all the movie titles and their plots and each URL of the movie so that we can visit back later, our goal is done. So from 2005 to 2021, we might have perhaps 3000 plus movies that we can collect and all their respective plots. That should be a great start. We can use that as the dataset for all our further exploration. So now you can get to the URL of each year. Now the data is stored in this format, and you need to see how you can parse this. So let's start with our Beautifulsoup library. Let's get into the coding section. So as you can see, I've given the link here where you have all the list of American films by year, and let's create each page link. We have seen that the page link just differs by, changing the year, appending the year at the end of this. So I'm just creating a base link that we have, Wikipedia/list of American films of _ and so let's run this. So essentially we are just appending the year at the end of this, and since it's 2005 to 2022, not inclusive of this in the range. We are going to get it till 2021. Let's just run this and see. So all we are doing is just collecting the URL of each year, and you know that we are simply appending from 2005 and increasing it till 2021 and printing it here. So we are going to collect movies from all these links. Let's just see whether any of the link works or not. Let's click on this. And you can see that we landed on this. So perfect. All these links are perfect. So far all we did was to collect the respective links of each year of American film from 2005 to 2021. Now let's actually start with the imports. Since we are going to open the URL of each year and collect all the data, we are going to use urllib.request library and also Beautifulsoup, like I mentioned. We are going to use these to parse. Let's just run this cell. These are the usual imports that we want. And for those who are very new, we need to kind of understand the HTML structure of this and parse accordingly. No matter what you're parsing, you need to first understand how it is structured and then go ahead with the parsing. So let's just go to this link, W3 Schools, to understand how the HTML structure looks like. So this is the basic HTML structure. And whatever you can see here, table, we need to see how it is actually in code. So this is the part where there is a header element, HTML element, and all the HTML elements that they are embedded within an opening tag and a closing tag, as you can see here, H2 and H2. H2 stands for header 2, and here similarly you have table tag and row tag, and you can see that the first row is actually table row with the header elements. TH stands for table header, and you know that company, contact, country, all these are in bold. And then you can see that you have table row with table data. So what you see, Alfred, Maria, Germany, is basically the first row here, and similarly this is the second row. So TR stands for table row and TD stands for table data, and simply you go on till the end how many rows you have. So this is how a table is created in HTML. Now let's go to this original HTML page, and let's just look at HTML formatting. Let's look at try yourself here. All I'm doing here is to just, whoever is very new to HTML, I'm just making them understand how HTML is structured. So you have the paragraph element P. Again, it's in between opening and closing, and if you want to make it bold, you have this B element, bold element, and you can see that the text here is bold. And the same text, this text is italic, is enclosed within an I element, which is italic element, and you know that the text is in italic. Similarly, you can take any text or word and embed within some HTML tags. This is the subscript tag and this is the superscript tag. You can see how it is subscripted and superscripted here. So essentially, just I want you to understand that HTML code looks like this, where every text is embedded within corresponding tags, and our goal when we are doing parsing is to narrow down to the exact element that we want and extract them. Great, let's continue ahead. So let's first parse the web page. For example, here we have American films of 2021. And let's just make sure if we can even get the web page content and parse it in our code. So all I'm doing here is I have this URL list of American films of 2021, and I'm using the URL open from urllib.request. And once the URL is opened, whatever the HTML is present, I'm giving the HTML to Beautifulsoup and asking it to parse it in the LXML format. Basically, it's an XML format so that you can find what you're looking for easily within the XML format. And once the soup element is loaded, all you're doing is to find the h1 tags, and you're iterating through the h1 tags and printing the h1 tag as well as the corresponding text. Let's run this. Awesome. You can see that you're printing the h1 tags, and this is the whole h1 tag content, and you're just getting the text within this list of American films of 2021. And why are we doing this? All we are doing is just understanding this web page. So in order to understand this web page, you can just right click on the page, inspect element, and wherever you are, if you're on Chrome browser, etc., it opens up like this. You know that click on list of American films, and you know that this is a corresponding part, and you know that whenever you highlight this, the list of American films is highlighted. So essentially, there's only one h1 tag in this web page, and the text corresponding to that is list of American films. And whatever you saw here in this web page, you're trying to see whether you can collect and identify the h1 tag. That's all what you're doing, which is in this code, you're opening up the URL, getting all the HTML code and passing on the HTML code to Beautifulsoup so that it organizes in LXML format. I mean, LXML is a Python library, and it's essentially used to convert this HTML code into XML format. And you can see that we are printing the whole h1 class, the whole h1 tag here, and we are extracting the text from it. So you know that at least the web page is loaded, and you are able to extract the main h1 tag. Now let's do the same thing, which is go through all the h2 tags and print them. And here I am printing all the h2 tags, which is content, box office, January to March, etc. Let's see. So you can see that box office, if you right click on it and inspect, you can see that it is h2 tag. And all we are doing is, after getting the h1 tag, we are getting the h2 tags. So box office, January to March, all this text, and again April to June, this text is in h2 actually. And why are we doing this is simply because before actually getting into each movie's link and extracting further data from it, we are just slowly, iteratively warming up ourselves to be able to fetch the data that we want. We are understanding how the page is structured and extracting elements one by one. Now let's go to the actual web page, and what we are interested is in getting all these titles, right? Not this, because we don't want just highest grossing films, rather all these titles, right? So let's just right click on it and inspect, because we need to see in which format it is. And if you look at the top level for January and March, you can see that the class is wiki table. So the table that corresponds to what we are looking for is actually named with the class wiki table. Great. So we identified more information on how to extract this. And let's also check this table. Okay, this is also wiki table. So we might have conflicts because just using the class wiki table doesn't necessarily suffice, because both this table and this table, both of them have wiki tables. So we need to use more things, which is, I can see that this has 4 columns and this has different columns, opening, title, etc. So perhaps we have seen in table header, right? You know what are the header tags, and using that perhaps we can filter. But before that, let's just extract all the tables and their headers that are titled as class wiki table. So you have seen that we have created the soup object already, and we have all the HTML content as XML data there. And here I am using the soup object, and I am just calling the find all function to find all tables that have the class wiki table. And we are iterating through each table, and we are getting all the headers in the table. Let's just run this, and you can see what we are doing here. Let's also go back to the UI. So essentially I'm getting all these tables, and from that table I'm extracting the headers, only the headers. So rank, title, distributor, domestic gross, opening, title, production company, cast and crew. And again, if you go from January, March to below, April, June, you'll have similar things. So you're going to get all these tables and their corresponding header names here, because within every table we are just finding headers and printing them here in the order. So rank, title, distributor, domestic gross, this is the first one. This is the first one essentially. This is also titled as header, that's why you're getting it here. And the next ones are actually the actual tables that we are looking for: opening, title, production company, etc. And now we have got what we want. Essentially, we want to find all tables, but we want to make sure that they start with opening, title and production company, etc. because we want to only get those tables, because from those tables we want to fetch the link for each movie and collect the movie plot. So now let's do something better. Instead of getting all the tables, why don't we check if at least 2 columns, let's say title and production company, is in the headers. We just want to make sure and keep only those tables where title and production company is there, because they are the relevant tables for us. Let's just run this. Great. Now we have title and production company, so we got only those tables, and you can see that there are 4 tables: January to March, April to June, July to September and October to December. As you can see, January to March, July to September, similarly October to December, etc. So we got only those tables. Now we are using the same code, and what we are trying to do is just print the first row, because we want to make sure that our goal is to get this right. So we got this table. Now we are just trying to see if we can print this row, the horizontal row right here. So from each table, once we have the table, we are just identifying all the table rows and just printing table rows from the first column, not the 0th column. Let's run this again and scroll to the top. As you can see, this is a full code where we are printing all the headers and we are printing each row, and you can see that Shadow in the Cloud, Vertical Entertainment, Rosalind Liang, all these are there. As you can see, this is the first row, Shadow in the Cloud, Vertical Entertainment and Rosalind Liang and all these things. So we are able to get each row. Similarly, you can get the second row, which is White Tiger, Netflix. So White Tiger, Netflix and other things. So we know that we can iterate through each row and just get the respective columns. But our goal is to get the actual link corresponding to this, because if you click on this, you can see that Wikipedia/Shadow in the Cloud is the actual link. We are interested in only this link because we want to extract the plot from this link. So instead of getting and printing all the rows, can we just get this row and this corresponding link, this column, actually only the title column. Let's first inspect to see how this looks like. So right click and click on inspect. So as you can see, it's within table row and table data, and within table data you have the italic one, and within italic you have ahref pointing to this link. So we want to actually extract this part. Now going back, we are able to get to the table row with our code. Now within the table row, we want to find the italic, because there is only one italic row. What I mean by that is, in this row there is only one italic text that's corresponding to this. So we are going to get the italic text, and within that italic text we are finding the first elements and getting the ahref of that. So that's in the title. So we are storing that in the title, the A element, the first italic element in the row and its corresponding A element, and within that we are extracting our href as well as the title tag. As you can see, in this row, this is the first italic element that we are encountering, that is 0th element. And if you click on inspect, you see that this is the first italic element, and within that you have a tag, and within that you want to extract this, the href link, as well as the title. Title is the name of the movie. So that's essentially what we are doing, and we need to combine the title href with the original wikipedia.org link and print the URL. Let's run this. As you can see, this is how the A tag with href looks like. Within that we are extracting the href, we are extracting the title, that is this. Now our goal is to get the movie title as well as the full link. And you can see it's the same for everything, which is you have the movie title, the full link. You have the movie title and the full link. So we have almost achieved our task, which is get the movie title as well as the corresponding link. And what remains is to go to each link within the movie title. For example, let's click on Long Weekend. Now our level 1 goal is achieved, which is from each year's movie page, we get all the movie titles and their corresponding links. Task 1 is achieved. Now task 2 is, again using Beautifulsoup, we go on to each movie's web page, and within that we need to extract the plot. Let's see that in the next section. For this section, we have achieved our task, which is given a year, we can get all the movies and their corresponding movie page links. As you can see, given a year like 2021, we can get all these titles and their corresponding links.